You know, I'm going to write this down. When two surfaces intersect, look at this now, intersect, they form a curve of intersection. I mean, they intersect in a curve, or maybe in a straight line. When we say the word curve, it definitely could be a straight line. But when two surfaces intersect, they form a curve of intersection, and that curve of intersection can be represented by a vector-valued function. Now, so then let's do an example. So here's two surfaces. Watch this. Z equals x squared plus y squared, and Z equals 4. So these are two surfaces. We studied surfaces in chapter 11. We should be sort of familiar with these surfaces. Although when I graded your test, no, I'm kidding. You did pretty good. Do you know what this one is?
Elliptical paraboloid.
Good. That's a paraboloid, and you called it an elliptic paraboloid, which is accurate. This one happens to be nice and circular, and here's a picture of him. And he goes forever. You know, he doesn't stop there. So you're right. That's a paraboloid. And what is that other guy? Oh, he's nice. He's just a plane, and not only he's a very nice plane, he's just a horizontal flat plane at z equals 4, which would be here. So he's a, you know what I mean? All right, what I'm interested in, though, is where do these two surfaces intersect? So you can imagine it. It's the paraboloid and then the plane. And where they intersect is, I'm not forming a solid. I just want to know when the two surfaces touch. Can you describe that to me? Do you know where that would be? When z equals 4 touches the paraboloid. I think it would be a circle. And I think it would be this circle.
Centered around the Z.
I think it would be a circle. Maybe you're right. The radius might be 2, but it's sitting at z equals 4. And here's what I want, though. This is a nice picture of it, which is cool, but that's the curve of intersection, and I want his equation. He's a 3D. He is sort of 3D. He's sort of 2D, but he's sort of 3D. I want his equation using a vector-valued function notation. The curve of intersection can be, there it is.
So it's 2 cosine t, 2 sine t, 0.
So he got, he decided he wanted circular motion in the xy plane. So he said let x be 2 cos t and let y be 2 sine t, and that'll get you a circular motion of radius 2.
But if you do a 4, that's...
But I don't want it at z equals 0. Where do I want it?
Well,
At z equals 4. And I don't want z to change, do I? So z is actually just stuck at 4.
Yeah.
So that's kind of a funny curve of intersection, but that's it. It's a circle up in the z equals 4 plane of radius 2. You know, when somebody makes you come up with a parametric equation, this was the best one, because if you got circular motion, you should use cosine and sine. You should. But you might not think of that. And what you might think is, here's a technique that sort of helps. I don't know, man. I'll let x be t. I'll just let x be t. We know z is stuck at 4. So now, can we find y? Well, if you go to that relationship up there on the paraboloid, if z is a 4, x is a t, can you find y? did X is, we let X be T. That was our choice. Z is a 4 though, there's no doubt about that. And then if we let X be T, Z is 4, can we find Y? Yeah.
Plus minus square root of 4 minus t.
Plus and minus the square root of 4 minus T squared is Y. You're right. And if I put this in here, this is also a description of this curve. This is the same curve. Using a plus and minus square root is not the funnest thing in the world, and if you're plotting points, it gets awful steep and funny. The best way to plot circular stuff is not with, the best way to plot circular stuff is to take advantage of cosine and sine parameterizations. But there's nothing really wrong with this. If the question was, can you come up with the parametric equation, please, or come up with the vector valued function, please. Both of these are correct. There might be more correct answers. There are more correct answers. Anyway, like I said, there's a little batch of homework that makes you do this. And I like this question. It ties our old knowledge of surfaces into curves just a little bit. The intersection of two surfaces is a curve. Okay. I think